Hi guys, welcome to class. So we're looking at this question under cyclotron motion, the motion of a charged particle in a magnetic field. The first question goes to us: an electron whose kinetic energy is 7.2 times 10 to the power of minus 18 joules is moving in a circular orbit of magnetic field of 9 times 10 to the power of minus 5 Weber per meter squared. Another unit for magnetic field or magnetic flux density aside Tesla is also what? Weber per meter squared. What is the radius of the orbit? The second question as well, electrons move at right angles to a magnetic field of 1.5 times 10 to the power of minus 2 Tesla. In this case, another unit is used, still the same unit. This Tesla is the same thing as this what? Weber per meter squared. With a speed of 6 times 10 to the power of 27 meter per second. If the specific charge of the electron is 1.7 times 10 to the power of 11 coulomb per kilogram, what will be the radius of the circular path? In these two questions, we are to calculate the radius of the circular path. Let's start with the first one. Now, as explained in our previous video, we have been able to derive the cyclotron formula, and the one that has to do with kinetic energy, the cyclotron frequency, as well as the period. So to start with the first one, to solve physics question, the very first thing to do is to write out your given parameter. The first thing is not formula. You need to write out your given parameters. So here we have our kinetic energy. Let's use K. This is solution 1. We are given our kinetic energy K to be 7.2 times 10 to the power of minus 18. That's joules. What are we given again? We are given magnetic field. That's B. That's 9 times 10 to the power of minus 5 Weber per meter squared, or Tesla. Then we have to obtain the radius. Other parameters are needed here. Yeah, they are needed. The mass of an electron, the charge of an electron. Yeah, the mass of an electron, that's mass, let's say M sub E, is approximately 9.11 times 10 to the power of minus 31 kilogram, while the charge of an electron Q is 1.6 times 10 to the power of minus 19 coulomb. That's the charge of an electron. So how do we plug it in to get the value of R here? Now recall that we've established earlier in a magnetic field, the radius is given by this square root of 2mk over qb. This is the formula to use to get in it. If you want to understand how this formula is derived, check our previous video on the cyclotron formula. Then we plug in your values, the radius becomes, we have 2, then the mass that we have of an electron, 9.11 times 10 to the power of minus 31. The square root continues. Then the kinetic energy, which is what? 7.2 times 10 to the power of minus 18. Everything over, then our charge of an electron, 1.6 times 10 to the power of minus 19 coulomb. Then the magnetic flux given to us, that's 9 times 10 to the power of minus 5. When you punch your calculator for this, you should be having the radius to be 0.25 centimeter, 0.25 meter, 0.25 meter. Then converting into centimeter, you need to multiply by 100. Then the radius of the circular path becomes 25 centimeter. I hope that is crystal clear. This is how to obtain the formula used in obtaining the radius of the circular path of a charged particle in a magnetic field. Thank you very much for watching.